Hello everybody, my name is Ro-Brotics and welcome to my very first tutorial. Today we are going to be doing something very simple. Today we are going to be programming the Arduino in normal code. The program I'm going to be using today, I'm not physically going to be using the Arduino and showing my Arduino. Because I don't have a top-down camera at this moment, what I'm going to be using is a program called Tinkercad. Now, it's a free and awesome program. I highly recommend it. Um, you can just go on it, sign up. There's classes to be had, as well as many different things that you can actually do inside of Tinkercad, like 3D modeling, code blocks, as well as circuitry. But for that, I am going to be using code blocks. If something else pops up, you're more than welcome to ask me in the comments down below. I will be more than happy to assist, as well as just help and make tutorials for my lovely viewers. But for this, we are going to be looking at the Arduino. We are going to be seeing normal basic programs that we can write for our very first program on the Arduino. Now, our very first program is actually quite simple. It revolves around the LED. What does LED stand for? Light emitting diode. So it's a normal diode, meaning it can only take power from one side to another. It unfortunately cannot take from both sides because it is polarized. I just want to, yeah, I said that correctly, yes. It is polarized, so it can only take from positive to negative. And with your LED, a normal way that you can think about it, your short leg is called the cathode, and where your long leg is called the anode. Think of the A as positive, a plus. You add something, where C, you see nothing. I don't know. It's just easier for me to remember. But for that, our Arduino has its very own LED built into it. So that is the program we're going to be writing today. So on Tinkercad, you can go to your circuitry and drag out your Arduino Uno R3. For that, we are going to be using the code editor built inside into the website. So I'm quickly just gonna take out the code here. Okay, so it is clean. Now for this, some of you may know Arduino already, but some of you who do game programming or have specialized in a few different scenarios when it comes to programming knows we know we have something called variables. The way variables works, it is almost like a box. It is a box with a name on, and whatever you want to do or whatever you want to program, that specified object you can place inside of the box. So let's say I want to program my shoe, right? For that, it can it be classified as a float value? If it was a float value, it would be one shoe and let's say one half. So for in this case, it is one shoe. So it's an integer, int value. And for that, you unfortunately cannot do that when it comes to LEDs. So let's quickly write our first step when it comes to our program. So it's int. It's an integer. So what do we want to do next? We firstly want to name what we want to do. So it is onboard LED. On board LED. And that is, I'm not really sure you have to specify it, but let's quickly test our system to see whether or not we should specify it. But for in this case, this is what I love about Tinkercad. You can try, and try again. Every time you fail, you can just stop the simulation and then try one code line at a time to see where the code isn't reading correctly. So for that, integer onboard LED, it's normally pin 13, but let's quickly just make sure. And then next, we want to initiate what we want to do. So it's setup. It's the very start of our program. So void setup. I'm so used to programming in C# for the capital start. Setup, braces, curly bracket. And this is where our very first program comes into play, the program that starts at the very beginning. So for this, I wrote setio instead of setup. So our very first program is to initiate what we want to do. So it will be pin mode, because it is a pin that we are going to be using. And then we have to tell pin mode what pin we want to identify. So for that, it is onboard LED. It's basically the on light, can we say. And we want to also tell pin mode what type of object it is. Is it the input device or is it the output device? So for that, it's an output device because it emits light. And there we go. You wrote your very first program, which is kind of cool. If you enjoy this type of content, please do leave a like down below and rate my content in the comment section down below. Next up, we wanted to loop the entire time. So for that, I'm sorry that I just smacked my mic with my finger. Yeah, we want the program to loop the entire time. So for that, what we can do is we can call this void function loop. And what we want to do inside of it, we actually want to notify our loop function what we want to do. So we want to write something to it. So for that, we are using a digital pin, which uses output. Well, when it comes to your input, it normally uses analog. Analog input, digital output, because it's something you physically see. Analog is something you control something else. Let's say an analog stick. It has the term built into its name, because on a controller, while you're playing, let's say GTA 5 or Elden Ring, you use the analog stick to move in and about. And for that, you are receiving digital information onto the screen for your character moving side to side, left and right, up and down, rolling, any type of that. It is analog to digital. So for that, I'm quickly gonna write for this, it is digital write. And I also want to specify what pin I want to write to. So it's onboard. Onboard LED, and I want to switch it on. So for that, you can think of it as binary. If it's switched on, it's 1, so the number is high. When it's switched off, it's low, so the number is 0. That is just the way I remember it, but I can also show you a different way of actually remembering it. So you want to write it high, because then it switches the LED on. So let's quickly just take a gander at our code, see whether or not we have written it correctly. I see. So there's no LED emitting. So let's quickly take a look at why this function doesn't want to work. Let's see whether or not pin 13 will fix the problem. There we go, it's emitting light. So that is something else that I really do like about this programming language. It's not as complicated as, let's say, HTML. I've never used HTML, but I'm not sure. I like basic programming like Arduino code, C Sharp, C++, as well as Python programming. So for this, I'm quickly going to stop the simulation. And what we want to do now, we want to delay the light. We want to keep it on for a certain amount of time. So for that, I gave the hint already. We want to delay the light. So for that, we write delay. And then we specify in milliseconds for how long we want to keep the lights on. So in Arduino code, you don't work with seconds. You work with milliseconds. So let's quickly take a look. If I write 1000 milliseconds as well as just put the semicolon, it is going to stay on permanently. So one way to actually test it is to copy this entire line of code. Just copy it and paste it down below. And then we can just edit out these lines. Just basically make it from a positive to a negative. So for this, I turned it to low. Let's quickly take a look. So it's going to be on, off, on, off. Let's see what else we can do. Let's try to switch it on for a quarter second. So that is 250. Let's stop the simulation. It is 250. And we want to keep it off for, let's say, half a second. So that is 500. Let's start the simulation and see what we get. So flashes, 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 flashes. Okay, that's kind of cool. What else can we do? Now, if you took a look at these headers, they have D1, D11, D12, D13. Those are digital pins. And if you look at the bottom right corner, you have A0, A1, A2, A3, A4, A5. For that, those are your analog in and digital write pins. Now, what I have explained is your LEDs are output devices. Let's see whether or not we can actually create our own circuit by using other let's just quickly take a look. Let's close our code editor. Let's take a small breadboard, a LED, as well as a 220 ohm resistor. 220. Now, what I also like about these give different types of ohm resistors. So for that, let's quickly place our ohm resistor over the gap, over the Grand Canyon. Now, also, you can change the light to any type of color that you really want. Now I'm gonna go for a bluish color. Let's go for blue. I like blue. Now they also specify this is the cathode lead and this is your anode lead. Anode addition, cathode negative. So let's also connect our wires to ground as well as positive. I am going to be using color coding system. So for this, the black is your ground. So I'm quickly going to connect it to my ground. There we go. Now it's earthed, as some people will say. And what do you think the next color will be? Okay, I'll quickly choose red. But for that, if you are living in South Africa, yeah, it won't necessarily be red. We have different color systems. Our Earth is yellow or green. When it comes to life, it is in this case red, but it can also be brown. And then you get your neutral color, which is blue. Um, yes. And now just to make this one red, just to keep with everything. So let's assign it to digital pin, let's say digital 11. Now, if we go back to our code, if we assign the blue LED, let's say int blue LED, and we assign the pin to pin 11, it is our digital pin 11, and you will see that squiggly line in front of the 11. That is no, you don't have to stretch about it. It's just to say that it is pulse width modulation compatible, meaning it can go on, go off, go on, go on, go off, go on, go off constantly without actually damaging the system. Where it comes to your normal 13, it can go off, go on, but it tries to limit itself. Whereas your digital PWM, it modulates with everything. It gives pulses as the code is read. So let's quickly take a look. Let's copy this and paste it underneath. And let's just quickly change the bit of code. Let's say blue LED. It's just a form of working quicker. Okay? Just to make sure our code is being read correctly. I am changing a bit of the variables. Blue LED. Okay, so this may be read a bit complicated because there is one being summoned out at this moment, but we can change that by changing it to pseudocode. So let's quickly start the simulation now. Ah, I got an error. What error is it? Okay, it says exit status. Why? Because I didn't use a semicolon. I used a colon. Let's start our simulation now. There we go. It's flashing. It flashes for a quarter second, stays off for half a second. So our code is working. In the next video, we are going to be talking about the RGB LED. I'm going to be demonstrating how to program the RGB LED to flash each color individually, as well as pulse through everything or breathe through all the different colors. But for that, what I will recommend is playing around with this, getting known to how to program in Arduino, as well as creating your own code. Let's say in the next video, I want you guys, or after this video, I want you guys to take a challenge upon yourself. I want you guys to add more than 3 different LEDs, and let them each be connected to their own digital pin, as well as different variables, different flashing speeds, as well as different colors. So I do want to see that in future, and I'm also going to be doing that in my next video, just to show you how I wrote my code. So yeah, this was actually really fun to make, and I really enjoyed it, and I hope you did as well. So for that, if you did enjoy it, please leave a like and leave a comment down below, and I will be more than happy to take a look at it. Thank you very much. I'm signing off. Cheers.